Galaxies are the grand architectural masterpieces of the universe, vast cosmic cities comprising billions or even trillions of stars, planets, nebulae, dark matter, and supermassive black holes. These celestial structures, ranging in shape from majestic spirals to enigmatic ellipticals and irregular clusters, have captivated humanity for centuries, igniting an insatiable curiosity about their origin, evolution, and destiny. Among them, the Sombrero Galaxy, or Messier 104, stands as one of the most striking and mysterious examples, a galactic enigma revealing the universe's complexity and grandeur. The Sombrero Galaxy, located approximately 31 million light-years from Earth in the Virgo constellation, earned its name due to its distinctive appearance. When viewed through telescopes, it resembles a wide-brimmed sombrero hat, thanks to its bright central bulge surrounded by a dark, sharply defined dust lane. This iconic structure represents a hybrid of galactic types, combining features of spiral and elliptical galaxies. The luminous core and large halo of globular clusters suggest an elliptical nature, while the prominent disk and dust lane highlight its spiral characteristics. This duality challenges traditional classification systems and invites deeper investigation into the processes that shape galaxies. Astronomical studies suggest that the Sombrero Galaxy is a massive object, containing roughly 800 billion solar masses. Its halo is populated by an exceptional number of globular clusters, up to 2,000, far surpassing the few hundred typically found in a galaxy like the Milky Way. This abundance raises questions about the galaxy's history and whether it formed through a series of mergers or evolved in isolation. Additionally, the Sombrero Galaxy's core harbors a supermassive black hole with a mass of about 1 billion times that of our Sun, further accentuating its role as a cosmic powerhouse. Modern astronomy relies on a combination of observational techniques and theoretical modeling to study galaxies like M104. Optical telescopes, such as the Hubble Space Telescope, provide high-resolution images, capturing the intricate details of the galaxy's structure. Meanwhile, radio telescopes delve into the cold, diffuse gas that fuels star formation, and X-ray observatories detect emissions from the hot gas swirling around its central black hole. Spectroscopy, a technique that analyzes the light spectrum emitted or absorbed by a galaxy, reveals crucial information about its chemical composition, motion, and distance. One of the most intriguing aspects of galactic research involves uncovering the role of dark matter. Observations of galaxies, including the Sombrero Galaxy, suggest that their visible mass, stars, gas, and dust, is insufficient to account for the gravitational forces required to maintain their structure. Instead, an invisible, enigmatic substance known as dark matter provides the necessary mass to hold these cosmic entities together. Studies indicate that up to 90% of a galaxy's total mass may be dark matter, yet its nature remains one of the greatest mysteries in astrophysics. The study of galaxies is not merely a pursuit of academic curiosity. It holds profound implications for understanding the universe's past and future. Galaxies are the fundamental building blocks of the cosmos, and their evolution is intricately linked to the history of the universe itself. The light we see from distant galaxies travels vast distances, allowing astronomers to peer billions of years into the past. By studying these ancient light sources, we reconstruct the timeline of the universe, from the Big Bang to the present day. The Sombrero Galaxy, with its unusual characteristics, provides a unique laboratory for exploring these cosmic questions. Its bright core offers a window into the behavior of supermassive black holes and their influence on surrounding stars and gas. The dust lane, meanwhile, serves as a site of active star formation, illustrating the cyclical nature of galactic evolution. Moreover, the halo's globular clusters may contain some of the oldest stars in the universe, offering insights into the early stages of galaxy formation. In recent years, advancements in technology have revolutionized our ability to study galaxies. Ground-based observatories equipped with adaptive optics can correct for the blurring effects of Earth's atmosphere, achieving near-space-level clarity. Space-based instruments, such as the James Webb Space Telescope, extend our reach into infrared wavelengths, penetrating the dust and gas that obscure visible light. These tools enable astronomers to study galaxies across the electromagnetic spectrum, uncovering hidden structures and processes. The exploration of galaxies also intersects with other scientific disciplines, such as cosmology and particle physics. The distribution and behavior of galaxies provide critical evidence for understanding dark energy, the mysterious force driving the universe's accelerated expansion. Observations of galactic clusters, the largest gravitationally bound structures, test theories about the nature of gravity and the large-scale structure of the cosmos. Despite these advancements, many questions remain unanswered. How do galaxies form and evolve over billions of years? What triggers the transition from active star formation to quiescence? How do interactions and mergers shape their structure? The Sombrero Galaxy exemplifies these mysteries, as its hybrid nature hints at a complex and perhaps turbulent past. Furthermore, the study of galaxies holds profound philosophical and existential implications. By examining these distant worlds, we confront our place in the universe. Galaxies are not static monuments but dynamic ecosystems, constantly evolving and interacting. They remind us that the universe is a vast, interconnected web of matter and energy, governed by the same physical laws that shape our own existence. In the coming decades, the quest to unravel the mysteries of galaxies will continue to drive innovation and discovery. Next-generation telescopes, such as the Extremely Large Telescope (ELT) and the Square Kilometre Array (SKA), promise to expand our understanding of the cosmos. These instruments will provide unprecedented resolution and sensitivity, enabling detailed studies of galaxies across cosmic time. As we gaze at the Sombrero Galaxy and its brethren, we are not merely observing distant objects. We are engaging in a profound dialogue with the universe, seeking to understand the forces that shape it and our place within it. The study of galaxies is a testament to human curiosity and ingenuity, a pursuit that transcends borders and generations, uniting us in a shared quest for knowledge and wonder. This extensive and enriched narrative captures the essence of galactic science and highlights the Sombrero Galaxy's allure and significance. Let me know if you'd like further elaboration or a specific focus on any aspect. The Sombrero Galaxy, often regarded as one of the most beautiful galaxies in the universe, is not merely an object of aesthetic fascination. It holds within it profound scientific puzzles that challenge our understanding of cosmic evolution. Imagine standing on the edge of its luminous disk, where the gravitational pull of billions of stars dances with the unseen forces of dark matter, shaping the intricate ballet of its structure. Every pinpoint of light in this galaxy represents a solar system, a potential cradle of life, and a glimpse into the vast possibilities of existence. What makes M104 particularly intriguing is the stark contrast between its bright, tightly packed central bulge and the thin, flat disk encircling it. This juxtaposition raises questions about its formation. Did it evolve in isolation, quietly accumulating mass over billions of years? Or did it endure violent encounters with other galaxies, merging and absorbing them into its structure? Theories abound, but definitive answers remain elusive, veiled behind the enigmatic glow of its stars and the cold embrace of interstellar dust. The supermassive black hole at the heart of the Sombrero Galaxy is another captivating feature. Black holes are the ultimate cosmic enigmas, regions where gravity is so intense that not even light can escape. In the case of M104, this black hole is estimated to be over 1 billion times the mass of our Sun, exerting a profound influence on its surroundings. The swirling disk of gas and dust feeding this gravitational monster emits high-energy X-rays, providing a rare glimpse into the violent processes occurring at galactic cores. These observations allow scientists to probe the relationship between black holes and the galaxies that host them, a relationship that remains one of the most profound mysteries in astrophysics. Zooming out, the halo of the Sombrero Galaxy reveals another layer of its story. This diffuse, spherical region is home to thousands of globular clusters, dense collections of ancient stars bound tightly by gravity. Each of these clusters is like a relic from the early universe, a fossilized record of the conditions that existed shortly after the Big Bang. Studying these clusters offers clues about the galaxy's formation history and the broader processes that shaped the cosmos in its infancy. Perhaps one of the most mind-bending aspects of studying galaxies like the Sombrero is the realization that we are looking into the past. The light from M104 takes 31 million years to reach us, meaning we see it not as it is today, but as it was when dinosaurs roamed the Earth. This concept, known as look-back time, transforms galaxies into time machines, allowing us to observe the universe's history unfolding before our eyes. Galaxies are not isolated islands floating in space. They are interconnected through vast cosmic structures, forming clusters, superclusters, and filaments that span millions of light-years. The Sombrero Galaxy resides near the Virgo cluster, one of the most massive galaxy clusters in the local universe. This cluster's gravitational influence, along with the mysterious push of dark energy, subtly shapes M104's trajectory. The interplay of these forces is a microcosm of the larger cosmic drama, where gravity and dark energy compete to define the universe's fate. Dark energy itself is a tantalizing concept, one that emerged from the study of galaxies. In the 1990s, astronomers discovered that the universe is not just expanding, it is accelerating. This revelation, awarded the Nobel Prize in Physics in 2011, suggests the presence of a mysterious force permeating space. Galaxies, as the visible markers of the universe's expansion, are key to unraveling this mystery. Observing how galaxies like the Sombrero move and evolve provides critical data for understanding the nature of dark energy and its implications for the ultimate destiny of the cosmos. But even as we look outward, the study of galaxies reflects back on us, forcing us to confront profound questions about our own existence. What role does Earth play in this vast cosmic tapestry? Are we an anomaly, a unique phenomenon in a universe dominated by lifeless gas and dust? Or are galaxies teeming with planets like ours, harboring lifeforms gazing back at the cosmos, wondering about their place just as we do? The Sombrero Galaxy, with its serene beauty and hidden complexities, invites us to ponder these questions. It beckons us to explore not just its physical structure, but the deeper truths it holds about the universe and ourselves. Every photon of light from its stars carries a story, a tale of creation, transformation, and endless possibility. And as our telescopes grow more powerful, as our understanding deepens, we edge closer to deciphering these tales, one galaxy at a time. The journey to uncover the secrets of galaxies like M104 is far from over. The universe is a living, breathing entity, constantly evolving and reshaping itself. The Sombrero Galaxy, though seemingly static in the cold depths of space, is part of this grand cosmic symphony, a symphony we are only beginning to understand. The more we learn, the more we realize how much remains unknown, how much wonder lies ahead. And so, we continue to look up, to question, to dream, knowing that each discovery is not an endpoint, but a new beginning. As we dive deeper into the mysteries of the Sombrero Galaxy and its kind, the questions only become more compelling. Why does this galaxy, with its serene, symmetrical structure, hold such an unusually large supermassive black hole? Could this central colossus be the key to understanding the galaxy's past? Black holes are often associated with chaos and destruction, yet in the case of the Sombrero Galaxy, it appears to contribute to a striking balance, a paradox that defies our expectations. The supermassive black hole at the core of M104 is not just a gravitational anomaly but a cosmic engine. Its immense mass allows it to control the surrounding gas, dust, and even entire stars. This process creates an accretion disk, an extraordinarily hot and bright structure formed as matter spirals into the black hole. The energy radiated by this disk is so intense that it can outshine the combined light of millions of stars. What's fascinating is how this energy can also regulate star formation, either by compressing gas clouds to trigger new stars or by blasting the surrounding area with radiation, suppressing stellar birth entirely. Understanding this delicate balance is essential for piecing together how galaxies evolve over time. The Sombrero Galaxy also serves as a cosmic time capsule. Its bright halo, filled with globular clusters, holds the secrets of the early universe. These clusters are some of the oldest known structures in the cosmos, containing stars that formed when the universe was still young and dominated by primordial elements like hydrogen and helium. By analyzing the light from these ancient stars, astronomers can decode the chemical fingerprints left behind, revealing when and where they were formed. This helps scientists reconstruct not only the history of M104 but also the broader story of galaxy formation. However, the Sombrero Galaxy is not just a relic of the past, it is an active participant in the present-day cosmic web. Galaxies are not solitary wanderers, they are part of vast, interconnected structures that stretch across the universe. The Virgo supercluster, where M104 resides, is a massive node in this web, connecting filaments of dark matter, gas, and galaxies. Dark matter, although invisible, plays a crucial role in this network. It provides the gravitational scaffolding that holds galaxies together and binds them into clusters. Without dark matter, the Sombrero Galaxy, along with every other galaxy, would simply fly apart. The quest to understand dark matter has led to some of the most ambitious experiments in physics. From underground detectors buried deep within mountains to particle accelerators like the Large Hadron Collider, scientists are hunting for elusive particles that could explain this unseen force. The Sombrero Galaxy's rotation curve, how its stars move at different distances from the center, offers compelling evidence for dark matter's presence. Unlike what Newtonian physics predicts, the outer stars in M104 rotate at speeds that suggest the galaxy is surrounded by a massive, invisible halo of dark matter. The Sombrero Galaxy also offers a lens into the future of our own Milky Way. In billions of years, the Milky Way and the Andromeda Galaxy are expected to collide, forming a new galactic entity. While such mergers may seem chaotic, they are part of the natural life cycle of galaxies. The Sombrero's peculiar structure, its bright core and extended halo, may be the result of a similar ancient merger, preserved in its serene appearance. By studying galaxies like M104, astronomers can predict the potential outcomes of such cosmic collisions, providing a glimpse into the distant future. Another captivating aspect of M104 is its star-forming regions, hidden within its dusty disk. Despite its old, massive halo, the Sombrero Galaxy continues to produce new stars, a testament to the dynamic processes within its structure. Star formation is not a uniform process, it requires the right conditions, a delicate interplay of gravity, temperature, and gas density. The dark dust lanes of M104, sharply etched against its luminous core, are the nurseries where these stars are born. Observing these regions in detail using infrared telescopes allows scientists to study how stars form under varying conditions, deepening our understanding of this universal phenomenon. And yet, for all its beauty and secrets, the Sombrero Galaxy reminds us of the vastness of the unknown. Its sheer scale, spanning 50,000 light-years, challenges our ability to comprehend the immensity of the universe. Within this single galaxy lie billions of stars, each potentially surrounded by planets, some of which may harbor the conditions for life. The search for extraterrestrial life is one of humanity's most profound endeavors, and galaxies like M104 provide countless opportunities for discovery. If intelligent civilizations exist elsewhere, they may also gaze upon their version of the Sombrero Galaxy, pondering their place in the cosmos as we do. The study of galaxies, including M104, is a multidisciplinary effort. Astronomers, physicists, chemists, and even biologists collaborate to unravel the complex tapestry of the universe. Instruments like the James Webb Space Telescope, JWST, have revolutionized our ability to study galaxies in unprecedented detail. With its infrared capabilities, the JWST can peer through the dust and reveal the hidden layers of the Sombrero Galaxy, uncovering new insights into its star-forming regions and central black hole. What's perhaps most thrilling is that every new discovery about galaxies like M104 opens the door to even deeper mysteries. Why do some galaxies stop forming stars while others remain active? What role do magnetic fields play in shaping their structure? And how does the interplay between dark matter and baryonic matter influence their evolution? The Sombrero Galaxy, with its iconic beauty and scientific complexity, is more than just a distant object in the night sky, it is a testament to the universe's creativity and the unyielding curiosity of humankind. It is a reminder that even as we uncover the secrets of the cosmos, the universe always keeps something more to reveal, an endless source of wonder and inspiration. And so, we look up, not just to observe, but to dream, to question, and to discover our place in this vast and astonishing cosmos. The Sombrero Galaxy is not merely a dazzling object suspended in the vast darkness of space, it is a cosmic laboratory where the laws of physics, chemistry, and cosmology converge, challenging the boundaries of human understanding. Its unique features provide an opportunity to explore some of the universe's most profound mysteries, from the nature of dark matter to the origins of supermassive black holes and even the potential for life in distant worlds. One of the most perplexing questions about galaxies like the Sombrero is the role of dark matter, the unseen mass that outweighs visible matter by a factor of about 5 to 1. Without dark matter, the rapid rotation speeds of stars in M104's outer regions would cause them to be flung into intergalactic space. Yet, they remain bound to the galaxy, circling the core as though held by an invisible hand. This phenomenon, first observed in the 20th century, was one of the key pieces of evidence for the existence of dark matter. But what is it? Is it made of exotic particles yet to be discovered? Or could it represent a flaw in our understanding of gravity itself? To explore these questions, scientists use powerful simulations. Supercomputers recreate the Sombrero Galaxy, incorporating the known laws of physics and different hypotheses about dark matter. These simulations are not mere theoretical exercises, they are predictive tools. By comparing simulated galaxies to the real M104, astronomers can refine their models, narrowing down the possible explanations for dark matter. Some theories propose particles such as WIMPs, weakly interacting massive particles, while others suggest entirely new frameworks for physics, such as modified Newtonian dynamics, MOND, or higher-dimensional effects. Beyond its dark matter halo, the Sombrero Galaxy's luminous central bulge offers a glimpse into the mysterious relationship between galaxies and their supermassive black holes. Unlike the Milky Way's black hole, which has a mass of around 4 million suns, M104's black hole tips the scales at a staggering billion solar masses. This vast difference raises critical questions. How do these behemoths grow so massive? Are they seeded by smaller black holes formed in the early universe, or do they grow primarily by consuming gas, stars, and even other black holes during galactic mergers? The black hole in M104 is remarkably quiet compared to the so-called quasars found in distant galaxies, where supermassive black holes voraciously consume matter, emitting blinding light across the universe. The Sombrero's subdued activity suggests it is in a dormant phase, but its past may have been far more dramatic. The surrounding globular clusters, relics from an earlier cosmic epoch, may hold the answers. These clusters could contain stars that bear the chemical fingerprints of intense energy outputs, such as those associated with an active black hole. Studying these clues could rewrite our understanding of galactic life cycles. The galaxy's dust lane, the dark band encircling its luminous core, is another area of intense scientific focus. These dense clouds of interstellar dust and gas are more than just visual features, they are the raw material for star formation. When gas clouds within these regions collapse under gravity, they ignite nuclear fusion, giving birth to new stars. Yet the process is far from straightforward. Magnetic fields, turbulence, and radiation pressure all compete to determine whether a star will form or the cloud will remain stable. Astronomers use advanced telescopes, such as the Atacama Large Millimeter/Submillimeter Array, ALMA, to probe these regions in exquisite detail. By observing the faint emissions from cold molecules, they can map the distribution and motion of gas in the dust lane. These observations reveal regions where new stars are likely to emerge and help answer broader questions about how galaxies like M104 sustain star formation over billions of years. But the Sombrero Galaxy does not exist in isolation. Like all galaxies, it is influenced by its environment. The interplay between galaxies and their surroundings, known as galactic ecology, is a burgeoning field of study. In the dense environment of the Virgo supercluster, gravitational interactions between galaxies can strip away gas, disrupt star formation, or trigger bursts of new activity. While the Sombrero appears relatively undisturbed, faint streams of stars or gas, known as tidal tails, could betray past encounters with smaller galaxies. These interactions are cosmic fingerprints, evidence of the dynamic forces shaping the universe on the largest scales. The Sombrero Galaxy also inspires speculation about the potential for extraterrestrial life. Within its disk, where stars are concentrated, there may be countless planets orbiting sun-like stars. Recent discoveries of exoplanets have shown that planets are more common than once believed, with many residing in the so-called habitable zone, the region around a star where conditions could support liquid water. Could some of these planets harbor life, perhaps even intelligent civilizations? If so, how would they perceive their place in the universe? And might they, like us, gaze at neighboring galaxies in awe, wondering if they are alone? The search for life extends beyond direct observation. Scientists study the chemical evolution of galaxies to understand the distribution of elements necessary for life. The Sombrero's globular clusters, for instance, contain ancient stars that formed when the universe was dominated by hydrogen and helium. Over time, nuclear fusion within stars has produced heavier elements, carbon, oxygen, nitrogen, the building blocks of life. By examining the Sombrero's chemical composition, astronomers can trace the processes that enriched its stars and planets with these life-sustaining elements. The future of galactic research promises even more profound discoveries. The next generation of telescopes, such as the Extremely Large Telescope (ELT) and the Square Kilometre Array (SKA), will provide unprecedented sensitivity and resolution. These instruments will allow scientists to study galaxies not just as they are today but as they were billions of years ago, when the first structures in the universe were forming. By observing galaxies like M104 in greater detail, we can piece together the history of the cosmos itself. The Sombrero Galaxy, with its serene beauty and hidden complexities, is a microcosm of the universe. It is a place where the forces of nature, gravity, radiation, magnetism, interact on scales both vast and minute. It is a testament to the ingenuity of humanity that we can observe and study such distant objects, deciphering their secrets from the faint light that reaches us across millions of years. And yet, for all that we have learned, the Sombrero Galaxy remains a mystery, a beacon of the unknown, urging us to continue exploring, questioning, and dreaming. The universe, it seems, always has more to reveal. The Sombrero Galaxy, despite its iconic appearance and relative proximity in cosmic terms, is a gateway to understanding phenomena that stretch the limits of human comprehension. Its features, ranging from its enigmatic supermassive black hole to its delicate dust lanes and ancient halo, are not isolated wonders but interconnected pieces of a grander cosmic puzzle. Each revelation about M104 serves as a stepping stone toward answering some of the universe's most fundamental questions, while simultaneously opening new doors of inquiry. Supermassive black holes, like the one at the center of the Sombrero Galaxy, remain one of the most perplexing and captivating phenomena in astrophysics. While these gravitational giants were once thought to be mere byproducts of galactic formation, recent studies suggest they may play a central role in shaping their host galaxies. Observations of M104 reveal a paradox: its central black hole is quiescent, yet the galaxy around it shows no signs of the violent upheaval often associated with such massive objects. Could this black hole have been more active in the past, shaping the Sombrero's structure through energetic jets and winds? Or is it lying dormant, awaiting a fresh influx of matter? Simulations of galaxy evolution have demonstrated that feedback from supermassive black holes, where high-energy radiation and winds push out surrounding gas, can regulate star formation. This process, known as AGN, active galactic nucleus feedback, prevents galaxies from growing uncontrollably large. The Sombrero Galaxy's bright, tightly packed core suggests a history of intense activity, even if that activity has now subsided. By studying the chemical signatures in its central region, astronomers can reconstruct its history, searching for evidence of ancient outbursts that may have shaped its luminous bulge and serene outer disk. One of the most fascinating aspects of studying galaxies like the Sombrero is the field of galactic archeology, the attempt to unravel a galaxy's history by studying its oldest components. The Sombrero's globular clusters, densely packed groups of ancient stars, are particularly valuable in this effort. These clusters are time capsules, preserving the conditions of the early universe when they first formed. By analyzing their metallicity, the abundance of elements heavier than hydrogen and helium, scientists can infer how and when the Sombrero Galaxy enriched itself with heavier elements. Interestingly, the Sombrero Galaxy's globular clusters show a bimodal distribution. Some are rich in heavy elements, while others are metal poor. This suggests that the galaxy may have grown through both internal star formation and external mergers with smaller galaxies. Each merger would have introduced new stars, gas, and dark matter, contributing to the galaxy's current structure. This duality makes M104 a prime example of how galaxies evolve through a combination of peaceful accretion and violent interactions. The Sombrero's prominent dust lane is not just a visual feature, it is a critical clue to its inner workings. This lane, composed of cold gas and dust, is where star formation occurs. However, unlike the well-defined spiral arms of galaxies like the Milky Way, the Sombrero's disk appears smooth and featureless. This raises intriguing questions. Is the dust lane a relic of a more active past, or is it the result of a unique process that inhibits the formation of distinct spiral patterns? Infrared observations have revealed that the dust lane contains a surprising amount of cold gas, the raw material for star formation. Yet, star formation in the Sombrero Galaxy is relatively subdued compared to more active galaxies. This suggests that something is suppressing the process, possibly the influence of its central black hole or the galaxy's unique gravitational dynamics. Understanding why star formation varies so widely between galaxies, and even within different regions of the same galaxy, is a key challenge in astrophysics. Zooming out, the Sombrero Galaxy is not an isolated entity but a part of the cosmic web, a vast network of galaxies, dark matter, and intergalactic gas that defines the large-scale structure of the universe. The Virgo supercluster, where M104 resides, is a bustling hub of activity, with galaxies interacting through gravitational forces. While the Sombrero appears relatively undisturbed, its history may include past interactions with nearby galaxies or even entire galaxy groups. These interactions can leave subtle imprints, such as streams of stars or gas extending from the galaxy's disk. These tidal features, though faint, are invaluable for reconstructing a galaxy's past. Observations of the Sombrero at extremely low surface brightness levels could reveal such features, offering new insights into its history of mergers and interactions. The Sombrero Galaxy, like all galaxies, holds the story of the universe within its stars and structures. Its oldest stars, formed less than 1 billion years after the Big Bang, contain the chemical fingerprints of the first supernovae, which forged the heavy elements essential for life. By studying the light from these ancient stars, astronomers can trace the chemical evolution of the cosmos, linking the formation of galaxies to the broader history of the universe. Furthermore, the Sombrero's striking resemblance to a hybrid of elliptical and spiral galaxies challenges traditional classification schemes. This hybrid nature may be the result of unique conditions during its formation, providing clues about the diversity of galactic evolution. Could the sombrero represent a transitional stage between different galactic types? Or is it an entirely unique entity, shaped by forces we have yet to understand? The Sombrero Galaxy's mysteries are not merely academic, they drive technological innovation and international collaboration. Upcoming missions, such as the Nancy Grace Roman Space Telescope, aim to map the universe's structure with unprecedented detail, shedding light on dark matter and the role of galaxies like M104 in the cosmic web. Ground-based telescopes like the Extremely Large Telescope, ELT, will peer deeper into the Sombrero's core, revealing the dynamics of its black hole and surrounding stars. Meanwhile, instruments like the Square Kilometre Array, SKA, will revolutionize our understanding of the intergalactic medium, the diffuse gas that connects galaxies. By studying how this gas interacts with galaxies like the Sombrero, scientists hope to uncover the processes that fuel star formation and regulate galaxy growth. As we gaze at the Sombrero Galaxy, we are reminded of the boundless potential of the cosmos. Each discovery about M104 is not just a step forward in science, it is a testament to humanity's ability to question, to explore, and to dream. The Sombrero is more than a galaxy, it is a symbol of the universe's endless capacity for wonder, complexity, and beauty. And as our tools grow more powerful and our theories more refined, the mysteries of M104 will continue to inspire the next generation of explorers, thinkers, and dreamers. The universe, vast and unfathomable, continuously reveals glimpses of its complexity, and among its celestial wonders, the Sombrero Galaxy stands out as a masterpiece of natural architecture. It beckons us not just with its beauty but with the secrets it holds, secrets that push the limits of our understanding and ignite our deepest curiosities. From the silent movements of its stars to the hidden forces shaping its evolution, the Sombrero Galaxy is a story waiting to be unraveled, a puzzle woven with threads of time, gravity, and light. Imagine standing at the edge of its luminous disk, surrounded by billions of stars, each one potentially hosting planets. The thought alone is staggering. What would those worlds look like? Could there be a planet with intelligent beings gazing back at their version of the cosmos, wondering if they too are part of something greater? The search for extraterrestrial life isn't just about finding biological traces, it's about connecting with something fundamentally universal, bridging the gap between what we know and what might be. The light we see from the Sombrero Galaxy today began its journey 31 million years ago, traveling across the silent expanse of space to reach our eyes. During that time, life on Earth evolved from early mammals to the dominance of humans. This simple fact, that light serves as both a messenger and a time machine, underscores the profundity of astronomical observation. Every photon captured in our telescopes carries with it the history of the galaxy, encoding events we are only now beginning to decipher. The intricate balance that allows galaxies like the Sombrero to exist is awe-inspiring. Gravity pulls stars inward, binding them into their orbits, while angular momentum prevents collapse, maintaining the graceful structure we observe. But beneath this apparent order lies chaos. Stars are born from collapsing clouds of gas, while others meet fiery ends as supernovae, scattering their enriched remains across the galaxy. These explosions forge the heavy elements essential for life, spreading them into interstellar space to be incorporated into new stars, planets, and perhaps even living beings. Every atom in your body was once part of a star that lived and died billions of years ago. This cosmic recycling connects us not just to the Earth but to the stars themselves. The Sombrero Galaxy's dust lane, dark and enigmatic, is more than a striking visual feature, it's a dynamic region where stars are actively forming. But why does the galaxy's star formation appear subdued compared to more active galaxies? Is it nearing the end of its life cycle as a star-forming system? Or is it in a delicate equilibrium, sustaining itself without the dramatic bursts of energy seen in younger galaxies? These questions are not just about understanding M104, they are about comprehending the life cycles of galaxies as a whole. The halo of the Sombrero Galaxy, vast and filled with ancient globular clusters, is another source of fascination. These clusters contain some of the oldest stars in the universe, formed when the cosmos was young and dominated by primordial gas. Studying them is like looking at a photograph of the universe in its infancy. What stories do these stars tell? What conditions led to their formation, and how have they survived for billions of years? The answers may reveal not just the history of the Sombrero but also the broader narrative of galactic evolution. Dark matter, the invisible glue that holds galaxies together, adds another layer of intrigue. The Sombrero Galaxy's rotation curve, how its stars move at various distances from the center, defies the predictions of Newtonian physics, pointing to the existence of dark matter. But what is dark matter? Is it composed of exotic particles, or does it hint at a fundamental flaw in our understanding of gravity? Experiments around the world are racing to answer these questions, but for now, the Sombrero remains a testament to the unseen forces that shape the cosmos. At its core lies a supermassive black hole, a gravitational monster whose presence defies comprehension. Unlike stellar mass black holes, which form from collapsing stars, these supermassive counterparts seem to have existed since the earliest epochs of the universe. How did they form so quickly? Were they seeded by the first stars, or did they grow through mergers and accretion over time? The Sombrero's black hole is relatively quiet today, but its past may hold clues to these questions. Could it have once been a quasar, blazing with energy as it devoured surrounding matter? And if so, how did it transition to its current dormant state? The Sombrero Galaxy also challenges our traditional classifications of galaxies. It exhibits features of both spirals and ellipticals, blurring the lines between these categories. This duality suggests a complex history, possibly involving mergers with smaller galaxies or interactions with neighboring systems. What processes led to this hybrid structure? Was it a slow, steady accumulation of matter, or a more chaotic series of events? Understanding these dynamics could reshape how we think about galaxy formation and evolution. Looking beyond the galaxy itself, we are reminded that it is part of a vast cosmic network. Galaxies are not isolated islands but are connected through the gravitational filaments of the cosmic web, a structure that spans the observable universe. The Sombrero Galaxy, nestled within the Virgo supercluster, interacts with this web, influencing and being influenced by its neighbors. These interactions, though subtle, leave lasting imprints, shaping the galaxy's evolution over billions of years. And yet, for all its grandeur, the Sombrero Galaxy is just one of trillions. Each galaxy, from the smallest dwarf systems to the largest ellipticals, tells its own story. Together, they form a mosaic of the universe, a tapestry woven with threads of light, matter, and time. The sombrero is a single thread in this tapestry, but it is a thread rich with detail and meaning, a reminder of the complexity and beauty that defines the cosmos. As we continue to study the Sombrero Galaxy and its counterparts, we are not just learning about distant objects, we are uncovering the mechanisms that govern the universe itself. Each discovery, no matter how small, brings us closer to understanding the origins, structure, and ultimate fate of the cosmos. The Sombrero Galaxy is a beacon of wonder and a challenge to our intellect, inviting us to look deeper, think broader, and dream bigger. In its light, we find not just answers, but the inspiration to keep asking questions. The Sombrero Galaxy, though seemingly serene and static from our distant vantage point, is in reality a dynamic and evolving entity, a microcosm of the universe's ceaseless activity. Beneath its tranquil facade lies a realm where stars are born and die, where invisible forces like dark matter sculpt its shape, and where the echoes of cosmic history reverberate across billions of years. Its very existence challenges us to confront the profound mysteries of space, time, and the nature of reality itself. The supermassive black hole at the heart of the Sombrero Galaxy, with a mass exceeding 1 billion suns, is a gravitational colossus whose sheer presence shapes the galaxy around it. Despite its dormancy, it exerts an invisible but profound influence, orchestrating the motion of nearby stars and gas clouds. Scientists theorize that such black holes may act as cosmic regulators, their energy output capable of either fueling or quenching star formation. Could this black hole's quiet nature be a sign of a galaxy in equilibrium, or is it the calm before another epoch of activity? Observing its subtle gravitational effects allows astronomers to probe the depths of the unseen, peeling back layers of cosmic history encoded in the orbits of the surrounding stars. The dust lane that encircles the Sombrero Galaxy, striking against the bright core, is not merely a backdrop to this cosmic wonder, it is an active, ever-changing environment where the building blocks of stars and planets reside. Molecular clouds within the lane, dense with gas and dust, are the nurseries where new stars are formed. Yet, the conditions for star birth are precarious, dependent on a delicate balance between gravitational collapse and the disruptive forces of turbulence, magnetic fields, and radiation pressure. Observing this process in detail with advanced telescopes reveals the intricate interplay of physics that governs the creation of stars, shedding light on how galaxies like the Sombrero maintain their luminous populations over billions of years. Further out, the Sombrero's vast halo is a region of intrigue, filled with ancient globular clusters and an abundance of dark matter. These clusters are fossilized remnants of the early universe, their stars formed from the primordial gases that existed shortly after the Big Bang. Each globular cluster is a snapshot of cosmic time, and their varying compositions hint at the galaxy's complex history of growth and interaction. The Sombrero's halo is unusually rich in such clusters, suggesting it has undergone a unique evolutionary path. Did it absorb smaller galaxies during its formation, each contributing its own cluster population? Or did it form in isolation, building its halo through internal processes alone? One of the most tantalizing mysteries of the Sombrero Galaxy lies in its hybrid nature. Its bright, spherical bulge is characteristic of elliptical galaxies, while its thin, well-defined disk aligns with the properties of spiral galaxies. This duality defies easy classification, prompting questions about its formation. Did it begin as a spiral galaxy that later accumulated a massive central bulge? Or was it an elliptical galaxy that developed a disk through subsequent interactions? The answer may lie in the galaxy's stellar populations. By analyzing the ages, compositions, and motions of its stars, astronomers can reconstruct its evolutionary journey, piecing together a narrative that spans billions of years. Beyond the Sombrero Galaxy itself, its context within the larger universe adds another layer of fascination. Galaxies are not solitary wanderers, they exist within a vast and intricate web of matter and energy. The Virgo supercluster, where the Sombrero resides, is one of the largest known structures in the cosmos, its galaxies interconnected by the gravitational pull of dark matter. These cosmic filaments, invisible to the naked eye, form the scaffolding of the universe, dictating the motion of galaxies and the flow of gas between them. The Sombrero's position within this web influences its evolution, as the gravitational tides of nearby galaxies subtly shape its structure and star formation activity. The discovery of dark energy has added yet another layer of complexity to the study of galaxies like the Sombrero. This mysterious force, responsible for the accelerated expansion of the universe, permeates space and affects the trajectories of galaxies on cosmic scales. While dark matter binds galaxies together, dark energy pushes them apart, creating a delicate cosmic tug-of-war. Observations of the Sombrero and its neighbors provide critical data for understanding the interplay of these forces, offering clues about the ultimate fate of the universe. Will the cosmos continue to expand forever, growing colder and darker as galaxies drift apart? Or will it reverse course, collapsing in a dramatic, big crunch? Despite the Sombrero's apparent tranquility, its past likely holds tales of dramatic collisions and interactions. Galaxies frequently merge in the cosmic dance, their stars and gas clouds intermingling in events that can trigger bursts of star formation or feed central black holes. The Sombrero's hybrid structure may be the result of such interactions, each one leaving behind subtle traces in the form of tidal streams, warped disks, or unusual stellar populations. Advanced imaging techniques, capable of detecting the faintest features, are beginning to uncover these hidden scars, providing a window into the chaotic processes that shape galaxies over time. In the search for life beyond Earth, the Sombrero Galaxy also plays a symbolic role. Within its disk, billions of stars may host planetary systems, some of which could harbor the conditions necessary for life. The discovery of exoplanets within our own galaxy has revealed a staggering diversity of worlds, from Earth-like planets in habitable zones to gas giants with exotic atmospheres. If planets in the Sombrero Galaxy share similar characteristics, they could be home to entirely different forms of life, shaped by the unique conditions of their environments. While direct exploration of these distant systems remains beyond our reach, their potential inspires us to continue searching for our cosmic neighbors. As technology advances, so too does our ability to study galaxies like the Sombrero in unprecedented detail. Instruments like the James Webb Space Telescope and the Extremely Large Telescope promise to revolutionize our understanding of the cosmos, allowing us to peer deeper into the universe and uncover the processes that govern its evolution. These tools will enable us to study not just the Sombrero's stars and gas, but the very fabric of space-time itself, probing phenomena such as gravitational waves and the nature of dark matter. The Sombrero Galaxy is more than a celestial object, it is a reminder of the vastness and complexity of the universe. It invites us to question, to explore, and to dream, challenging us to look beyond our immediate surroundings and consider our place in the cosmos. Each discovery about the Sombrero is a step closer to understanding the universe's grand design, yet it also serves as a humbling reminder of how much remains unknown. In its light, we find not just answers but the inspiration to continue the journey of discovery, fueled by the unquenchable curiosity that defines us as a species. The Sombrero Galaxy continues to captivate not just as a celestial wonder, but as a symbol of the universe's boundless complexity and mystery. The more we study it, the more we realize how deeply interconnected its components are, and how they reflect the larger processes at play throughout the cosmos. It is a galaxy that defies simple classification, a hybrid of elegance and enigma, inviting us to unravel its secrets. The galaxy's core, shining like a brilliant lighthouse in the dark sea of space, tells the story of incredible forces at work. Supermassive black holes like the one at the center of the Sombrero are known to influence their surroundings in profound ways. Though this particular black hole is dormant now, scientists believe it may have once been an active galactic nucleus, a quasar so luminous that it could have outshone the entire galaxy for millions of years. Such energy bursts would have had the power to reshape the galaxy's structure, pushing gas outward and halting star formation while enriching the intergalactic medium with heavy elements forged in the stars. But why has the black hole gone quiet? Could it reignite in the future? Black holes feed on matter, and if new material, gas, dust, or even an entire star, wanders too close, the dormant giant could awaken in a spectacular blaze. Observations from the latest generation of X-ray and infrared telescopes may reveal signs of this slow-motion drama, showing subtle shifts in the black hole's environment that could signal its next act. The Sombrero Galaxy's unique dust lane is another source of intrigue. Dust, often thought of as a nuisance obscuring stars, is actually one of the most important ingredients in the universe. It is within these dense regions of gas and dust that stars are born. But why is the Sombrero's dust lane so sharply defined? Most spiral galaxies exhibit sweeping, winding arms rich in star-forming regions, yet the Sombrero's disk remains relatively featureless, almost minimalist. Could it be the result of a past merger that redistributed the galaxy's material into this unusual configuration? Or is it governed by internal forces, such as the gravitational effects of its dark matter halo or the influence of magnetic fields threading through its disk? The halo of the Sombrero Galaxy offers an entirely different perspective. Extending far beyond the visible disk, this halo is a vast sphere of influence, populated by ancient globular clusters and infused with dark matter. It is a treasure trove of information about the early universe. Each globular cluster, a compact group of stars bound by gravity, acts as a fossil, preserving the conditions of the universe as it was billions of years ago. These clusters formed before the Sombrero Galaxy itself took shape, providing clues to the processes that led to galaxy formation. One of the most compelling features of the halo is its connection to the concept of galactic archeology. By studying the motions, compositions, and ages of the stars and clusters in the halo, astronomers can reconstruct the galaxy's formation history. They can identify remnants of smaller galaxies that were absorbed into the Sombrero over billions of years, tracing the paths of these ancient cosmic collisions. These mergers are not just violent events, they are also creators, seeding the galaxy with new stars, enriching its gas with heavy elements, and contributing to the growth of its central black hole. The Sombrero Galaxy's place within the cosmic web adds yet another layer of intrigue. This web, an intricate network of galaxies, dark matter, and intergalactic gas, is the universe's scaffolding, dictating the movement and evolution of galaxies on the largest scales. The Sombrero, situated within the Virgo supercluster, interacts subtly with its neighbors through gravitational forces. These interactions may strip away gas, ignite bursts of star formation, or leave faint tidal streams, ethereal trails of stars torn from other galaxies. Searching for these faint imprints requires the most sensitive telescopes, capable of detecting light billions of times fainter than the night sky. While the Sombrero Galaxy is a wonder in its own right, it also serves as a key to understanding broader phenomena, such as the nature of dark matter and dark energy. Dark matter, the unseen mass that holds galaxies together, is evident in the Sombrero's rotation curve, how its stars move at different distances from the center. The outer stars orbit far faster than they should based on visible matter alone, revealing the presence of a massive, invisible halo of dark matter. But what is this mysterious substance? Experiments on Earth are attempting to detect dark matter particles directly, while cosmological simulations use galaxies like the Sombrero to refine their models of how this invisible matter shapes the universe. Dark energy, even more mysterious than dark matter, governs the expansion of the universe itself. Observations of galaxies like the Sombrero provide critical data for understanding this enigmatic force. By measuring the distances and velocities of galaxies, scientists have discovered that the universe is expanding at an accelerating rate, driven by dark energy. The implications are profound. If dark energy continues to dominate, the universe could end in a big freeze, where galaxies drift so far apart that their light can no longer reach each other, leaving a cold, dark cosmos. Galaxies like the Sombrero may hold clues to how this process unfolds and what it means for the future of the universe. Yet, even as we grapple with these grand questions, the Sombrero Galaxy invites us to consider the possibility of life beyond Earth. Within its disk, billions of stars may host planetary systems, some of which could have the conditions necessary for life. The search for exoplanets in our own galaxy has revealed a stunning variety of worlds, from Earth-like planets to gas giants with exotic atmospheres. If life exists in the Sombrero Galaxy, it could take forms we cannot even imagine, shaped by environments vastly different from those on Earth. The idea that intelligent beings may be observing their version of the universe from within M104 is both humbling and exhilarating. As our telescopes become more powerful and our computational models more sophisticated, the mysteries of the Sombrero Galaxy will continue to unfold. Each discovery adds a new layer to our understanding, not just of this particular galaxy, but of the universe as a whole. The Sombrero is a reminder that science is a journey, one fueled by curiosity and driven by a desire to explore the unknown. In its light, we are connected to something far greater than ourselves, a cosmos that is as vast as it is beautiful, as mysterious as it is inspiring. The Sombrero Galaxy stands as a beacon in the night sky, urging us to keep looking upward, to keep questioning, and to keep searching for our place in this extraordinary universe. It is not just a galaxy, it is a reflection of the infinite possibilities that await us, a reminder that the greatest discoveries may still lie ahead. The Sombrero Galaxy, M104, serves as a cornerstone for scientific research, offering insights into some of the most profound mysteries of astrophysics. From its unique structural features to the underlying forces that govern its evolution, the Sombrero represents a microcosm of the complex processes shaping the universe. Ongoing research into this galaxy not only enhances our understanding of its distinct characteristics but also sheds light on universal phenomena that apply to galaxies throughout the cosmos. Dark matter remains one of the most perplexing and significant subjects in astrophysics. Observations of the Sombrero Galaxy's rotation curve provide compelling evidence for its existence. The stars and gas in the galaxy's outer regions orbit far faster than they should if only visible matter were present. This discrepancy suggests the presence of an enormous halo of unseen mass enveloping the galaxy. To probe this enigmatic force, scientists use sophisticated simulations that mimic the behavior of galaxies with varying dark matter distributions. By comparing these models to observations of the Sombrero Galaxy, researchers refine theories about the properties of dark matter. Some experiments, like those conducted at the Large Hadron Collider or deep underground detectors, aim to directly detect dark matter particles, while others focus on its indirect effects, such as gravitational lensing. In the case of the Sombrero Galaxy, its massive halo bends the light of background objects, providing another way to study the elusive substance shaping its structure. The Sombrero's prominent dust lane is a site of ongoing star formation, though at a subdued rate compared to more active galaxies. Recent studies using telescopes like ALMA, Atacama Large Millimeter/Submillimeter Array, have revealed intricate details of the molecular gas within this lane. Molecules like carbon monoxide, CO, which emit radio waves detectable at millimeter wavelengths, serve as tracers for the cold gas essential for star birth. These observations have highlighted pockets of dense gas where gravitational forces are overcoming internal turbulence, leading to the formation of new stars. Understanding why the rate of star formation in the Sombrero Galaxy is relatively low compared to other spiral galaxies is a critical area of research. It could be due to environmental factors, internal feedback from the galaxy's central black hole, or the influence of its dark matter halo. The Sombrero Galaxy's bright bulge and extended halo make it an excellent target for studying chemical evolution. By analyzing the light spectra of stars in these regions, astronomers can determine their chemical compositions, ages, and motions. This data provides a timeline of the galaxy's enrichment with heavy elements produced in supernovae and other stellar processes. The Sombrero's halo, populated with thousands of globular clusters, contains some of the oldest stars in the universe. These clusters are relics from an earlier era, formed when the universe was still dominated by hydrogen and helium. By studying their metallicity, the abundance of elements heavier than helium, researchers can infer the conditions of the early universe and the processes that led to the galaxy's formation. The bimodal metallicity distribution observed in the Sombrero's globular clusters suggests a history of both internal star formation and external mergers, providing critical clues about its evolutionary path. At the heart of the Sombrero Galaxy lies a supermassive black hole with a mass of approximately 1 billion suns. Studying this gravitational giant provides insights into the relationship between black holes and their host galaxies. Observations of the stars and gas orbiting close to the black hole reveal its mass and influence on the surrounding region. One area of interest is the role of the black hole in regulating star formation. Through a process known as feedback, energy released by the black hole can heat or expel gas, suppressing star formation. While the Sombrero's black hole is currently dormant, its past activity may have played a critical role in shaping the galaxy's structure. High-resolution X-ray and infrared observations are being used to search for evidence of past outbursts, such as shock waves in the surrounding gas or unusual chemical signatures. The Sombrero Galaxy's classification as a hybrid between a spiral and an elliptical galaxy makes it a fascinating subject for theoretical modeling. Spiral galaxies typically have prominent disks with well-defined arms, while elliptical galaxies are characterized by their spherical or oval shapes and lack of disk structures. The sombrero, with its bright bulge and extended disk, exhibits features of both. Theories suggest that this hybrid structure may result from a combination of internal dynamics and external interactions. For example, a past merger with a smaller galaxy could have triggered the formation of the massive central bulge while preserving the disk. Alternatively, the sombrero may have formed in a region with unusually high density, allowing it to accumulate both spiral and elliptical characteristics. By modeling the gravitational dynamics and chemical evolution of the galaxy, scientists aim to uncover the processes that led to its unique appearance. While the Sombrero Galaxy appears relatively undisturbed, researchers suspect that faint tidal features may exist, revealing evidence of past interactions with other galaxies. These features, such as stellar streams or warped disks, are the remnants of gravitational encounters that redistribute stars and gas. Detecting these faint signatures requires advanced imaging techniques, often at extremely low surface brightness levels. Upcoming telescopes, such as the Vera C. Rubin Observatory, will have the capability to detect these subtle features, providing new insights into the sombrero's past. By studying tidal remnants, researchers can reconstruct the galaxy's interaction history and test theories about its growth through mergers. The Sombrero Galaxy also contributes to our understanding of the universe's large-scale structure and the role of dark energy. Observing its position and motion within the Virgo supercluster helps map the distribution of matter and the influence of cosmic expansion. The study of galaxy clusters, including the Virgo cluster, has revealed that the universe's expansion is accelerating, driven by a mysterious force known as dark energy. By measuring the sombrero's redshift and comparing it to theoretical models, astronomers refine estimates of dark energy's properties. This research has profound implications for the ultimate fate of the universe, whether it will continue expanding forever or eventually collapse in a big crunch. Advancements in technology promise to transform our understanding of the Sombrero Galaxy and others like it. Instruments like the James Webb Space Telescope are capable of peering into the galaxy's dust-shrouded regions, revealing the birthplaces of stars and the dynamics of its central black hole. Ground-based observatories, equipped with adaptive optics, can resolve individual stars in the galaxy's halo, providing unprecedented detail about its oldest populations. Meanwhile, the next generation of cosmological surveys will map the universe in greater detail than ever before, placing the Sombrero Galaxy within the broader context of the cosmic web. These efforts will not only deepen our understanding of M104 but also provide a more complete picture of how galaxies evolve within the universe's vast and intricate network. The Sombrero Galaxy, with its striking appearance and scientific richness, is far more than a distant object in the night sky. It is a window into the processes that shape the cosmos. Each discovery about this galaxy serves as a stepping stone, bringing us closer to answering the grand questions of existence. How did the universe begin? What forces govern its structure and evolution? And what is humanity's place in this cosmic tapestry? The Sombrero Galaxy reminds us that science is not just a pursuit of knowledge but a journey of discovery, driven by an insatiable curiosity to understand the universe and our connection to it. The Sombrero Galaxy stands as a monument to the boundless intricacy and beauty of the universe. It is more than a distant, luminous object. It is a gateway to understanding the forces that shape existence on the grandest scales. From its enigmatic supermassive black hole to its serene halo populated with ancient stars, Every aspect of M104 tells a story of cosmic evolution, interconnected with the broader tapestry of the universe. As humanity peers deeper into the galaxy's mysteries, the Sombrero continues to challenge our understanding, urging us to refine our theories and expand the horizons of what we know. Its unique structure blurs the boundaries of classification, revealing the interplay of gravitational dynamics, chemical processes, and cosmic collisions. It reminds us that galaxies are not static entities but living systems, evolving through cycles of creation and destruction, influenced by forces both visible and invisible. The Sombrero Galaxy also serves as a poignant reminder of our own place in the cosmos. Within its disk and halo are billions of stars, each with the potential to host planets, some perhaps teeming with life. It invites us to wonder, if intelligent beings exist somewhere in the galaxy, are they too captivated by the stars, asking the same profound questions about their origins and destiny? Science has allowed us to study this majestic galaxy in exquisite detail, yet it also humbles us with the realization that we have only scratched the surface of what remains to be discovered. The Sombrero is not just a subject of study, it is a symbol of the limitless curiosity that drives us to explore, to learn, and to connect with the vastness beyond our world. In the coming decades, as new technologies and missions unlock deeper layers of the universe, the Sombrero Galaxy will remain a cornerstone of scientific inquiry, a celestial guide leading us toward answers about dark matter, dark energy, and the origins of galaxies. It reminds us that the universe is both a puzzle to solve and an endless source of wonder. Ultimately, the Sombrero Galaxy stands as a beacon, illuminating the infinite potential of human exploration. It inspires us to look upward, not just to admire its beauty but to embrace the challenge of discovery. In its light, we find the courage to ask the boldest questions, the persistence to seek the deepest truths, and the humility to recognize the profound interconnectedness of all things in the cosmos. It is a reminder that as we explore the universe, we are, in a sense, discovering ourselves, a small yet significant part of a vast, dynamic, and extraordinary whole.